All right, let's dive right into this explainer by looking at a pretty fascinating paradox. To make artificial intelligence smarter, more intuitive, and just, completely invisible in our daily lives, like the facial recognition on your phone or the voice assistant in your smart car, it actually requires a massive, physical, and unbelievably expensive infrastructure. We're talking about an endeavor that honestly rivals space exploration in its sheer cost and complexity. So welcome to an exploration of the true cost of AI and the Blackwell revolution that's aiming to change the whole game. So how much does artificial intelligence really cost? It's a question most of us never ask, right? We just type a prompt into a chatbot and boom, the answer appears like magic. But we're going to tease apart that mystery for you today. Most people don't realize the staggering physical and financial capital required to power the AI we literally use every single day. If you peek into the financial records, the raw numbers are absolutely breathtaking. They reveal this high-stakes race where only the ultra-wealthy can even afford to compete.
Here is our agenda for today. We're going to map out this economic journey by looking at 1. The artificial intelligence winter. 2. The true costs of hardware. 3. The Blackwell architecture revolution. 4. Energy efficiency and sustainability. 5. Extraordinary financial results. And finally, 6. The future of the AI market.
Let's kick things off with Section 1, the artificial intelligence winter.
AI hasn't always been this booming, well-funded powerhouse that it is today. In fact, the original AI winter wasn't a failure of ideas, it was a failure of funding. Back in 1950, Alan Turing was already researching human intelligence emulation. But by the 1970s and 80s, the whole industry just froze. Why? Because computational power and data were simply way too expensive. Computers were locked away in prestigious university research centers. Private investors wouldn't risk a dime because the economic return seemed so incredibly distant and insecure. It actually wasn't until NVIDIA commercialized the first GPU in 1999, which, combined with the rise of the internet, provided that vital technological spark to get things moving again.
Moving right along to Section 2, the true costs of hardware.
While the tech has definitely advanced, the financial barriers have only gotten steeper. If you search through the SEC's EDGAR database and really dig into the filings from major tech companies, the sheer capital intensity of this industry just leaps right off the page. Get this, the microelectronics industry routinely spends about 20% of its revenue just building new factories. On top of that, another 12 to 15% goes directly into research and development. Testing new processors and materials requires pilot lines that demand investments comparable to building particle accelerators. Building hardware for AI is literally one of the most expensive human endeavors in history, which drastically limits the number of companies like Intel, AMD, and NVIDIA who can even afford to participate.
Which brings us to Section 3, the Blackwell architecture revolution.
So how do you solve this massive cost barrier? Well, you have to look at a fundamental revolution in architecture. Because if computing power remains this expensive, the whole AI boom is mathematically unsustainable. Consider this. To train a massive 1.8 trillion parameter GPT model using NVIDIA's older Hopper architecture, it would take 15 megawatts of power and 8,000 GPUs running for 3 whole months. But with the new Blackwell architecture, training that exact same model takes only 4 megawatts and 2,000 GPUs in the exact same time frame. Blackwell isn't just a cool tech upgrade, it is a fundamental economic revolution that slashes those hardware requirements and infrastructure costs drastically. To put that into perspective, over the last 8 years, NVIDIA has increased computational power by a factor of 1,000. The superchip GB200 Grace Blackwell boasts an absolutely incredible 40 petaflops of AI performance, delivering 30 times the throughput per GPU for AI inference. In the real world, this vastly reduces the cost of generating tokens, the basic building blocks of text and language models. It basically democratizes access, meaning companies can now run real-time AI applications without needing to build a billion-dollar data center.
Next up, Section 4, Energy Efficiency and Sustainability.
In the world of mega data centers, hardware efficiency directly equals energy sustainability. 30 trillion watt-hours. That is the estimated annual energy savings if global data centers shifted their high-performance computing and AI workloads from traditional CPUs over to GPU-accelerated infrastructure like Blackwell. To give you a sense of scale, that is enough energy to power 4 million homes for an entire year. It really highlights that the next frontier of AI isn't just about getting smarter, it's about getting leaner.
All right, let's look at Section 5, Extraordinary Financial Results.
Now let's talk about how these new technologies are radically transforming corporate balance sheets.
In just the first quarter of the 2024-2025 fiscal year, NVIDIA brought in $26.04 billion in revenue. That is an astounding 234% year-over-year growth that completely shattered market expectations. Earnings per share jumped by roughly 400%. To truly understand the scale of this wealth generation, we kind of have to look at global monetary policy. While central banks like the Federal Reserve and the European Central Bank are meticulously tweaking interest rates and managing asset purchase programs just to maintain a baseline of 2% inflation and economic stability, this single tech sector is experiencing explosive sovereign-level wealth generation.
And the market has definitely noticed. Institutional investors hold nearly 67% of NVIDIA's shares. The wider financial market has completely bought into this capital-intensive, high-reward infrastructure model. This massive influx of institutional belief is exactly what pushed the company's valuation past that unbelievable $3.35 trillion mark.
Finally, Section 6, the future of the AI market.
So, can this blistering pace continue forever? Right now, NVIDIA's reach is incredibly broad. They're fending off AMD in graphic chip design, they're battling Meta, Alphabet, and Microsoft in metaverse architectures, and they're competing against heavyweights like IBM, Intel, and Amazon Web Services in AI platforms. But because of those extreme capital costs we discussed earlier, the particle accelerator level investments just to build a pilot line, the competitive landscape is inherently fragile.
Because the baseline financial costs of these AI factories are so astronomical, experts are actually anticipating a slowdown in this explosive growth rhythm. The market is inevitably heading toward a consolidation where only the richest, most heavily capitalized players can survive. And beyond just the pure economics, whoever remains at the top is going to have to face looming legislative challenges regarding copyright infringement, data usage, and the ethical deployment of AI.
Which brings us to our final thought. Will the extreme infrastructure costs of artificial intelligence inevitably result in an unstoppable market oligopoly? The original AI winter happened because compute was too expensive. Today, compute is incredibly powerful, but the cost to manufacture the underlying hardware is consolidating power into the hands of a very select few. I want you to really consider this. Will the very nature of AI's extreme hardware cost dictate who controls the future of our technology? It's a massive question we'll all be answering together over the next decade. Thank you so much for joining me on this explainer. Keep questioning the systems behind the screens.